Alrighty, Course 3 students, we are on to lesson 3.2 in our graphing and functions unit. 3.2 is called just graphing on a coordinate plane, which is a lot of the stuff I tried to kind of review with you in the thoughts that you had seen this prior. And some students have, some students are a little more struggling on that, and that's okay as we continue on. Talking about graphing points, figuring out how to put them on a coordinate grid, so on. So our objective today is I can graph points on a coordinate grid. So be able to graph them as well as understand where they are on a graph, you know, what quadrant, those kind of things. So we're going to continue practicing this skill. But there is a lot of things within understanding and graphing, you know, a coordinate grid point. There's a lot of different wording and a lot of different things to understand how they work. So these key ideas, there's a lot of different things in here, so I'll stop and pause on a few things. But it says the coordinate plane is formed when two lines, the x-axis and the y-axis, they intersect at right angles and divide the plane into four quadrants. So we've got an x-axis, we got a y-axis. Okay, those are the two main lines on there. You can see them shown on this grid. Here's my x. Oh, I don't know if I can draw over the actual picture. Here's the y, and it creates four different quadrants. It says that the x-coordinate is the first number in an ordered pair. Hey, we've been talking a lot about that. Maybe it's just because my pen's not in right now. We've talked a lot about how, you know, that first number in an ordered pair is your x. So in this case, here's your x is 2. The second one would be y. So it says then the y-coordinate is the second number. To plot an ordered pair, we always begin at what is called the origin, or 0, 0. So thinking about 0, 0, if they had then the point 2, 3, 2 is going to show me I'm going to go slide over to 2, and then I'm going to go up 3. I guess I actually made a little dark. Up to 3. So that first number just tells me if I go left or right. So that's something else you could write. X goes left or right. That might be a helpful tool. Whereas y goes up or down. That is something also very helpful. So talking about my origin, which is 0, 0, it is the intersection of the x and the y-axis. The x-coordinate tells us how many units left or right. So again, here's where I was telling you, y goes up or down. So in this case, if I have the point 2, 3, that means I move right 2 and move up 3. If it's going to be a negative number, I would say I move to the left 2, and maybe I have a point like negative 2, maybe I have a point like right there. So I'd move left 2, down 2. So again, thinking about you start here, which directions are you going, okay, as we go around. So a lot of different kind of wording. Remember your quadrants, we always start in this top right one, and then it goes the opposite way a clock would go. So it's going to go around this way. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. And they always use Roman numerals for it. Don't ask me why. It's just a math thing, I guess. I'd be curious to know. Alrighty, so our first example just says that given the coordinates, I think I wrote the directions wrong. Give the coordinates and quadrant for each point. So we need to figure out where these points are at. So I'm just going to start writing them. Okay, here's P, here's M, and it looks like we also have N. All right, so looking at P, remember we want to look for that X and that Y. So how far over, if I start at my origin, how far over did I go? I go 1, 2, 3, 4, 5. So I'm going over negative 5. And I'm not going up or down. So in this case, since I just stayed on the line, my Y is going to be 0. This also gets tricky when you talk about quadrants, because it's technically not in a quadrant. It's not in that kind of box. And so if you were following along with that IXL topic that we did, I think it's the P2, this one we would just say, instead of quadrant, we'd just say on the, the x-axis. So it's on the x-axis. Here's the x, that's why it's on that line. So if you run into something like that, you can always just say on the x-axis if that's where it is, or if it's on the y-axis, say the y-axis. So looking at M, if I start at my 0, I'm going to move over 1, 2, 3, 4, it looks like, and I go up 1, 2. So I'm going to have 4, 2. In this case, thinking about my quadrants again, I'm going to be in quadrant 1. Quadrant 1 or 1. I know I put the Roman. This isn't the Roman numeral. It should go like that. And then N. N looks to be, if I go for my 0 here, remember I always go left or right first. So I'm going to go left 1, 2, 3. So it means -3. I'm going to write that first before I do anything else. And then I'm going to go down 1, 2, 3. So again, I'm going down. That's going to show also a negative. So -3, -3. In this case, thinking about my quadrants, this is quadrant 1, quadrant 2. This one's quadrant 3, and that's where my N is. Quadrant 3. Remember that last quadrant is 4, and this is how they write it in Roman numerals. A line and then a V. Alrighty, so this next one is they give me the coordinate point. Sorry, the light's kind of funny right now. They give me the point or where they want each point to go. They give me the directions. So I will be a little more specific as we get to these, but let's start by looking at A. So they just want me to graph each point on the coordinate grid. A is at 2.5 and 5. Remember, X is first, Y is second. So 2.5, so I'm going to move 2.5 to the right. So starting at my 0, 0, 1, 2, and I want 0.5, so I'm going to be kind of in the middle between 2 and 3. And then I want to go up to a positive 5. And I know these lines get a little tricky with all of this. So I'm just going to put my dot, and here's A. For B, I'm going to be a little more specific. I'm going to rewrite this because typing it out is hard. It says 0 and 4 and 1/2. Okay, that's what I was trying to do. So in this case, I'm going to start at 0, 0. If I have a 0 at the beginning, I don't go left or right. I stay here. So then all I have to do is go up. I want to go up then, or up or down, and in this case I want to go up, so I'm going to go up to 4.5. So 1, 2, 3, 4, and I'm going to go right in the middle here. Because 4.5 is right in the middle between 4 and 5. So here's my B. C, again, I'm going to rewrite this one a little bit. So it's -1 and 1/2, and then 2.7. So with this being the fact that I don't have, you know, all these decimal numbers, make a good educated guess on where you think it would go. So if I'm going to start here, and I'm going to go over to -1 and 1/2, it's going to be in between -1 and -2, so right in the middle. But then I want to go up to 2.7. Well, okay, I'm going to go up to 2 first. Well, 2.7 is in between 2 and 3. And actually, 2.7 is a little closer to 3 than it is to 2. So maybe I'm going to put it like right there. We're going to call that C. Then my last one's a little more straightforward. D, I got 2.3. So I'm going to go over to 2.3. That's going to be in between 2 and 3. Thinking about my 0.3 then, that's going to be a little closer to 2, so maybe I'm going to want to come here. And then I'm going to go down to 3. I would say about there. Call that D. Okay? So as long as it's pretty much within that space, that looks correct. Obviously, if you had something, you know, like B way up here, it's not going to be correct. But if it's in the close proximity, and having, you know, it's relatively can see that that's that value, you will be good. I think we have one more example here. Yeah, last one. So this is something we haven't talked about quite yet, which is finding the distance between 2 points. So in this case, there's a couple ways you can do this. I want to show you the easiest way first because I think that's what most people are going to take away from this. So say find the distance between each pair of points. So in this case, I'm going to go between A, so here's my A, and B. I got Christmas colors here. One way we can do this is we can just count how many boxes are in between them. Because they're on the same line here, they go to the same spot, they both have that same Y value, I can just count my spaces. So 1, 2, 3, 4, 5, 6, oh gosh, 7, 8, 9, 10. So I could say 10, boom. But another way you can think about it is you can find the difference between these two numbers, okay? So -6, finding difference, -4. But if you remember, at one point I told you distance was never, ever negative. So when we do this, we put absolute values around them. Well, a negative minus a negative is like saying negative plus a negative. Negatives just add and keep the negative. So in the absolute value, I'd have -10. Absolute value of -10 is 10. So one way you do it, they get the same answer. So same thing I can do for C. If I wanted to, I could sit here and count up all these numbers, but maybe I don't want to. Maybe I just want to do that other way. So in this case, what actually is the numbers that are the same are X. So in this case, I would want to find the difference of these Y numbers. So I would take 7 minus -4. Take that absolute value. Hey, we have a minus a negative. Minus a negative, which means actually we're adding it, adding a positive. So 7 plus 4 equals 11. Looks really weird if you put it in the absolute values in 11. But I could also sit here and go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, did I not do this right? Did I count this wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think what did I do wrong? I think I might have mislabeled something here. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My apologies. I see the mistake here. It took me a minute. This should actually be the coordinate point 8. Because knowing this is a line 1, 2, 3, 4, 5, 6, 7, 8. So that would be an 8 here. And that is my mistake. So then really 8 plus 12 is, 8 plus 4 is 12. And that's why I got it correct then when I was counting them. That was an error on my mistake, not mathematically on that side. So thanks for bearing with me. So you can use either method to solve out those and find the distance in between them. This only works if they are within, if they are kind of in that same line of each other, whether it's the X or the Y line. When we get into funky things like trying to figure out between D and B, there's a completely different kind of formula for that. Or if I wanted to go from C to A, because it's a diagonal, it's going to be a little more tricky. Okay, so we will continue on practicing these skills here in class, and I will see you then. Make sure to ask your questions.